You know, when you hear the word quality, what actually pops into your head?
I mean, for a lot of people, it's usually luxury, right?
Right. Yeah. For a long time, I always thought of it as this, transcendent ideal, like a handmade sports car or a perfectly tailored suit.
Oh, sure. A watch that costs more than your house.
Exactly. But then think about like a solid $2 plastic pen that you just buy at the pharmacy. If that thing never skips, if it writes smoothly every single time, is that low quality?
Well, no. And that's the thing. What if quality has absolutely nothing to do with luxury?
Right. What if it's just about giving the customer exactly what they expect every single time?
It's a huge fundamental shift in perspective. And frankly, it is where a lot of businesses get completely tripped up. We tend to, conflate quality with high grade or prestige.
Yeah, the shiny stuff.
Exactly. But in the business and manufacturing world, a low-grade product can actually be of extremely high quality.
As long as it works.
Right, provided it perfectly conforms to its specifications and meets the user's actual needs. I mean, a basic economy car that runs reliably for a decade, that is a high-quality product, even if it has cloth seats and manual roll-up windows.
Okay, so let's unpack this, because today we are taking you on a deep dive into total quality management, or TQM.
It's a massive topic.
It really is. We're going to lay out the roadmap for how organizations actually build quality into their DNA rather than, just slapping it on a marketing brochure.
Which happens way too often.
Oh, all the time. So we'll explore a foundational philosophy called Jurin's Trilogy. We'll uncover the hidden and honestly massive costs of poor quality.
Yep, the financial side is eye-opening.
Totally. And then we're going to dive into exactly how companies solve these really complex problems using two heavy-hitting frameworks, the Basic 7 and the 7 new tools of quality.
And if we connect this to the bigger picture, you really need to understand that quality isn't just some, nice-to-have added value.
Right, it's not a bonus.
No, it is an absolute essential requirement for survival in any market today. Total quality management is all about securing long-term success through absolute customer satisfaction.
So it's about minimizing variation in your processes.
Exactly. And fundamentally, it requires empowering your employees to own that quality on the floor every single day.
So before we start looking at the specific tools and like data charts, we need a blueprint, right? How do companies actually structure their approach so that quality isn't just an empty buzzword on a motivational poster in the break room?
Right, the classic hang in there cat poster.
Exactly. We need something real.
You definitely need a structural philosophy first. And that brings us to Jurin's Trilogy. A lot of organizations use this specific framework to build their entire quality initiative from the ground up.
And it has 3 parts, obviously.
As the name suggests, yes, it's broken into 3 distinct phases. But what is truly brilliant about Jurin's approach is that each phase is executed by a completely different level of the company hierarchy.
Oh, so it forces everyone to participate.
Exactly. It's not just siloed to one department. The first phase is quality planning.
And this is happening at the very top, right? Like senior leadership, the executives.
Yes, executed by senior leadership. Quality planning is where you look outward. You define who your customers actually are and determine their exact needs.
So finding the product market fit.
Right. Once you know that, leadership develops the product, the process, or the service requirements to meet those specific needs. They are the ones building the core features and the strategic transition plans to bring this thing to life.
Okay, so that's phase 1. The executives make the plan. But, executives aren't the ones actually turning the wrenches on the factory floor. So how does that translate down the chain?
That is where phase 2 comes in, which is quality control. And this is typically executed by middle management.
The supervisors.
Yeah. This phase is all about maintenance, monitoring, and holding the line. Middle management determines what actually needs to be measured in the daily operations to ensure the executive's plan is actually working.
Got it. So they set performance goals, measure the actual performance against those goals, and then act on any gap between the two.
Precisely.
So if the plan says we make 100 widgets an hour, middle management is the group actually counting the widgets and figuring out, why we only made 90 today.
Yes. Which naturally leads to the final phase.
Right. Quality improvement.
Exactly. Quality improvement is executed on the ground by team leaders and the employees themselves. It's the hands-on daily work of just making things better.
Right. The sources actually categorize this into 4 R's, don't they?
Yes. Repair, refinement, renovation, and reinvention.
A great analogy for you to visualize this whole structure is opening a restaurant.
Oh, I like that.
Yeah, think of Jurin's Trilogy like the kitchen hierarchy. Senior leadership, so the owners, they do the quality planning. They design the concept, figure out the neighborhood demographic, and they write the menu based on what people want to eat.
Okay.
Then you have the kitchen manager or the head chef doing quality control. They are literally standing at the pass, tasting the soup, measuring the temperature of the steaks to make sure every single plate matches the owner's vision.
And then the quality improvement phase.
That's the line cooks. The people actually doing the work, they are the ones constantly tweaking their chopping techniques, reorganizing their prep stations to shave off a few seconds, figuring out how to communicate better during the Friday night rush so the food gets out faster.
That is a perfect way to visualize it.
Yeah.
Everyone has a highly specific role, but the entire system is universally oriented toward that final plate of food reaching the customer exactly as expected.
Yeah, and if the line cooks figure out a faster way to prep the food, that quality improvement piece, it eventually feeds back up to leadership, who can then plan an even better menu.
It's a continuous loop.
But here's where it gets really interesting. If the framework is so clear, planning, control, improvement, why do so many companies still put out terrible products?
Yeah.
I mean, we all have horror stories of buying something that just breaks on day 2. Why is quality such a struggle?
Well, simply put, because investing in quality costs money up front. And humans are notoriously bad at prioritizing long-term savings over short-term expenses.
Right, we want the quick win.
Exactly.
Yeah.
It requires resources, time, and absolute commitment from management. But what companies often fail to realize is this concept known as the cost of poor quality.
Oh, this part blew my mind.
Yeah, the sources highlight a truly staggering statistic. If an organization puts very little effort into preventing errors up front, about 80% of their quality costs end up being costs as failure.
Wait, 80%? Just bleeding money because things went wrong?
Yes. 80% of their quality budget is just putting out fires.
Mm-hmm.
And we can break those failure costs down into 2 categories.
Okay, let's hear them.
First, you have internal failure costs. This is when things go wrong before the product ever leaves the building. We're talking about rework, literally throwing away defective parts as scrap.
Or dealing with long lead times because you had to redo a whole batch of products that just didn't pass the final test.
Exactly.
Which hurts the bottom line, obviously.
Yeah.
But, I mean, at least the customer didn't see it. It's embarrassing for the factory, but it's not as bad as the second category.
Right, because the second category is external failure costs.
Yeah.
This happens after the product has reached the customer.
So warranties, returns, product recalls.
Yes, and the sources are incredibly explicit here. This is by far the most expensive kind of failure.
Because it leads to lost customers.
Exactly. The financial impact of a lost customer, a ruined reputation, a viral social media post about your broken product, it's incredibly difficult to measure on a spreadsheet, but it is utterly devastating to a business.
So if 80% of your costs are stemming from these failures, where should the money actually be going? Like, how do you flip that ratio?
The money should be going into controlling quality costs, which are also broken into 2 proactive buckets, appraisal and prevention.
Okay, appraisal first.
Appraisal costs involve things like finished good inspections, making sure the process conforms to specifications, calibrating your testing equipment. You are actively appraising the quality before it leaves the door.
Got it. And prevention.
Prevention costs go even further upstream. This is investing in preventive maintenance for your machines, intense education and training for your workers, and auditing your suppliers so you only get good raw materials in the first place.
Okay, I have to play devil's advocate for a second here. Because if I'm a factory manager, my goal is to produce as much as possible, as cheaply as possible.
Naturally.
So what does this all mean for the bottom line? You're telling me that spending more money on training programs, paying inspectors, and deliberately taking a $1 million machine offline for routine maintenance actually makes the product cheaper to produce overall.
It sounds totally counterintuitive, but yes, absolutely. And this raises an important question about the trade-off, which is visualized in what we call the total quality cost curve.
Yeah.
In the short term, yes, your costs go up because you're making a deliberate investment. But not investing is exponentially more expensive in the long term because of the multiplier effect of a failure.
Oh, because preventing a defect costs $1, finding it in the factory costs $10, and having the customer find it costs $100.
Exactly. Imagine a graph in your head right now. As a company approaches 100% conformance, meaning 0 defects, the cost for appraisal and prevention do rise.
Right. It takes immense effort to be perfect.
But as you reach that near-perfect state, your failure costs, Those massive, unpredictable bills for rework, warranties, and lost customers, they absolutely plummet.
Oh, wow.
And because failure costs drop so drastically, they drag the total cost of quality down with them.
It's the classic, an ounce of prevention is worth a pound of cure just applied to corporate finance.
That's exactly what it is.
Okay, so we know we need to prevent failures. We know we need to control the process. We have Duran's philosophy. We have the financial motivation of the cost curve. But how do we actually do it?
Like practically.
Yeah. If I'm a manager on the floor and suddenly our defect rate spikes, how do I actually solve that problem?
That is exactly where the Basic 7 or the B7 tools of quality come in. The B7 is a collection of hard, data-driven tools used to track, visualize, and analyze numerical data.
So you can figure out exactly what is causing the variation in your process.
Precisely.
Instead of just listing these out, let's actually put them into practice for the listener. Let's pretend we manage a bicycle factory.
Okay, I'm with you.
And suddenly, we are getting flooded with external failures. Customers are returning our newest mountain bike because the chain keeps snapping. It's a total disaster. Where do we even begin?
You begin with data collection. Before you can solve a problem, you need to understand its scale and frequency. So the first tool you reach for is the check sheet.
The check sheet.
It is incredibly simple, but foundational. You give your inspectors a structured form, and every time a bike comes back, they just put a tally mark next to the specific issue.
So they're literally just tracking, 5 bikes had flat tires, 2 had chipped paint, and 45 had snap chains.
Exactly. And once you have that raw data, you can use another tool, like a histogram. A histogram is a vertical bar chart showing a frequency distribution.
Oh, okay. So if we are looking at those snap chains, the histogram might show us exactly where on the chain the break is happening.
Right. Are they all breaking at the master link? Or is it a natural, random distribution across the entire chain? It helps you visualize the central tendency and the spread of your actual data.
Okay, so our check sheet and histogram tell us we definitely have a massive problem with the chains. But a factory is a complex place. We might have 50 different issues going on at once. How do we know what to prioritize?
That's where you use the Pareto chart. This is based on the famous 80-20 rule.
Right, the Pareto principle.
It's a specific type of bar chart that helps you identify the significant few causes of problems versus the trivial many.
So when you plot all your factory's defects on a Pareto chart, it visually highlights the main culprits.
Exactly.
Yeah.
It shows that while you might have 50 different reasons for customer returns, just 2 or 3 of those reasons, like the snap chain and maybe a faulty brake cable account, for 80% of the actual volume of returns.
It cuts through the noise. It tells leadership exactly where to aim their fire.
Right.
You don't spend a week trying to fix a rare chipped paint issue when chains are snapping left and right. You focus on the big bars first.
Precisely.
Yeah.
So now you know what the biggest problem is,
Right.
but you still don't know why the chain is snapping.
And this brings us to one of my absolute favorite tools, the cause and effect diagram, widely known as the fishbone diagram. This is where we start doing detective work.
What's fascinating here is how it structures your team's brainstorming.
Yeah.
You draw a horizontal line with the problem, which is the snap chain at the head of the fish.
Right.
Then you draw branch lines out to identify all the major categories of possible causes.
Yeah.
You look at the environment, the people, the materials, the methods, and the machines.
And here is a highly specific technique from the sources that you can apply right now. When you use the fishbone diagram, you don't just stop at the first cause you find. You use a mental model called the 5 whys.
Yes.
You literally just ask why 5 times to drill down to the ultimate root cause.
Let's run through it with our bicycle factory.
Okay, so why is the chain snapping? Because it's being stretched too tight during assembly.
That's one why.
Right, but don't stop there. Why is it being stretched too tight? Because the assembly machine is misaligned. Why is the machine misaligned? Because the calibration gear is worn out.
Keep going.
Why is the gear worn out? Because it wasn't lubricated last month. Why wasn't it lubricated? Because the maintenance mechanic was pulled onto another job due to a staffing shortage. Boom!
Wow.
You just went from a snap chain on a mountain trail to an HR staffing issue in the factory.
It's incredibly effective. It forces you past the symptoms and into the disease. You can use the 5 whys in your own daily problem solving, whether it's at work or, trying to figure out why your personal budget is always off every month.
It's such a powerful mental model. So let's say we fix the staffing issue, we grease the gears, and the machine is perfectly aligned. How do we make sure it stays that way? Like, how do we monitor it over time?
That is where the heavyweight of the B7 group comes in, the control chart. Specifically, something like an X-bar chart. A control chart tracks a sample mean over time.
Okay, so imagine taking the average tension measurement of 5 bike chains every single morning and plotting that average on a line graph that stretches across the month.
Right.
Wait, I'm a little confused on the mechanics here. I've seen these charts, and they always have these horizontal lines running across them, the upper and lower limits. Is management just guessing where to draw those guardrails? How do they know what is acceptable?
It's a great question. And no, it's not a guess at all. This is pure statistics. The chart includes a population mean in the center, your ideal target.
Okay.
The upper control limit, the UCL, and the lower control limit, the LCL, are mathematically calculated based on the statistical standard deviations of your actual process. Every process in the universe has natural variation. No machine is perfect down to the atom.
So as long as our daily chain tension measurements bounce around randomly inside those statistical guardrails, we're okay.
Exactly. If the points are inside the limits and random, your process is in control. It's experiencing what we call common cause variation. It's predictable.
But what if it isn't?
If a data point suddenly spikes above the upper control limit, or if you see a non-random pattern like 6 days in a row where the tension is steadily increasing, the chart is screaming at you.
It's telling you something fundamentally changed.
Yes, it tells you a special cause has entered the system. Maybe a new batch of raw steel is harder than usual, or a sensor got knocked out of place. The control chart lets you catch the error before it turns into a defective product that reaches the customer.
It really is the voice of the process speaking to you. So if we look at the whole B7 toolkit, we have 7 tools in total, including things like flowcharts for mapping steps and scatter charts for finding correlations between 2 variables.
Right.
They are incredibly powerful, but they all share one big limitation. They require hard data. You have to be measuring something that already exists.
Right. And that is a significant constraint, because what if your problem isn't numbers? What if your problem is organizing a giant, messy brainstorm?
Or what if you are planning a really complex new product launch where you don't even have a factory line or data yet?
Exactly. If I'm on the factory floor tracking chain defects, I'm reaching for the B7. But if I'm in a conference room designing our next generation of electric bicycles, I need something different.
That is where you turn to the 7 new tools of quality, or the N7, where the B7 is for hard data. The N7 is designed specifically for ideas, planning, and mapping out complex relationships.
Let's take our bicycle company into the boardroom. We want to launch a brand new e-bike. The room is chaotic. Everyone has different ideas about what features it should have. We need to make order out of chaos.
The first tool you reach for in the N7 is the affinity diagram.
Yes. If you've ever had a massive brainstorming session where everyone writes ideas on sticky notes and throws them on a whiteboard, it's just a sea of noise.
It's overwhelming.
An affinity diagram is the systematic process of organizing all those chaotic individual ideas into natural related groupings so you can actually make sense of them. You group all the battery ideas here, the frame ideas there, the software ideas over here.
It turns 100 random thoughts into 4 distinct categories we can actually manage.
Exactly.
But once we have those categories, how do we decide which features to actually build? Our engineering team can't do everything. We have to make choices.
That's where you might use the prioritization matrix. This is brilliant for comparing how potential product features fit along 2 different competitive ranges.
Okay.
You create a simple graph with an X and Y axis. For our e-bike, maybe the X-axis is battery range and the Y-axis is total weight.
Oh, I see. Because usually a bigger battery means a heavier bike. They fight against each other.
Exactly. So you plot your different design concepts on this matrix. You can instantly see visually that concept A has incredible range but is way too heavy, while concept B is light but won't last a 10-mile commute.
So by visualizing the trade-offs, it helps the leadership team prioritize which features they actually need to develop based on where the gaps are in the market.
It makes objective decision-making entirely visual and objective.
There are 7 tools in the N7, including things like tree diagrams to break big goals down into smaller tasks, and activity network diagrams, which map out complex project timelines to find the fastest path to completion.
Right.
But one of the most critical for a new launch is the Process Decision Program Chart, or the PDPC.
That sounds incredibly academic. What is a PDPC in plain English?
It is essentially rigorous contingency planning. When you are launching this new e-bike, the PDPC visually outlines all the proactive steps you need to take to ensure the launch succeeds, specifically focusing on what could possibly go wrong.
Ah, so it's institutional pessimism.
In a good way. You map out, what if the battery supplier goes bankrupt 2 weeks before launch, or what if the shipping containers are delayed? You map out countermeasures for every scenario in advance so nothing is missed when the pressure is on.
Okay, let's take a breath. We have covered a massive amount of ground today.
We really have.
We started by challenging what the word quality even means. We looked at the organizational philosophy of Duran's trilogy, how executives handle planning, middle management handles control, and workers drive improvement.
We also confronted the financial reality. That staggering statistic that 80% of quality costs are failure costs if you don't invest in proactive prevention and appraisal.
And then we got our hands dirty. We used the B7 tools like the Pareto chart and the control chart to dig into hard data and solve the mystery of the snapping bike chains.
And finally, we used the N7 tools like the affinity diagram and the prioritization matrix to organize the messy human side of launching a brand new product.
It's a comprehensive, incredibly powerful toolkit. But it all comes back to that initial mindset shift. Quality isn't just an inspection checkpoint at the end of the factory line. It's a culture woven into every single step, from the boardroom down to the mechanic maintaining the machines.
And I want to leave you, the listener, with one final provocative thought to mull over. The sources note that one definition of quality is value-based, meaning value for money based on perceptions.
Okay.
And ultimately, the customer is the ultimate definer of what quality is. Think about what that really means for a business. You could have a mathematically perfect manufacturing process. You could be utilizing Duran's trilogy flawlessly.
Right.
You could have your B7 control charts updated perfectly, showing absolutely zero variance in your bicycle chains.
But, and this is the kicker, if customer expectations shift overnight, say maybe a competitor releases a hover bike or a new cultural trend emerges that makes e-bikes uncool, your mathematically perfect product's quality instantly drops to zero in the eyes of the market.
Exactly. Quality isn't a finish line you cross, wipe the sweat from your brow, and say, we did it, we're perfect forever. It's a moving target you have to constantly, relentlessly chase.
Yeah.
Your control charts only measure what you tell them to measure. They don't tell you if the customer even wants the product anymore.
Which is why that continuous connection to the customer's needs and the organizational agility to adapt your plans is the true beating heart of total quality management.
A perfect place to wrap up. Thank you for joining us on this deep dive. Go out there, grab a sticky note, and try using the 5 whys to solve a problem in your own life today. See you next time.